Basically, as you remember, we talked about the linked list last time, and we compared the linked list with array list as well. But first, we decided that we're going to implement our linked list, and then we're going to move to also implement our array list as well. So linked lists are basically going to be the chain of nodes, right? So we created this class node, and then every time that we're going to add our basically nodes to this list, we need to make sure that there is another class that is going to maintain this list. And so we call that class is the linked list class itself, right? So the node's going to be maintained by the linked list class itself. So we implemented the linked list class, and we also implemented the node class. So let's now look at the code. And also I'm trying to share it here for all of you. Perfect. Okay, so so far this is what we did. We had our node class. Inside the node, we're only going to have the elements that we're going to store, and this is the singular linked list basically. So it's only going to have a reference to the next node, so we only know who's the next. And then also we're going to now implement our own linked list. In the linked list, we're going to maintain our chain of all these nodes. We're going to have a reference to the very first and the reference to the very last node only. And since each node is going to know who is the next, that way we can find any of the nodes inside our linked list. But if you don't know who is the first node, then we're definitely going to lost all the data that we stored in this linked list. So basically we have a chain of link, nobody pointing to them, and a chain of nodes in the memory, nobody pointing to them because we lost the first one, and so the garbage collector is going to collect them. So we have to make sure that every time we're adding new items or new nodes to our list, we're going to making sure that we're maintaining the value of first and last, so we don't lose them. So we talked about how we're adding element to the list, right? So we have two ways to add the element into this linked list. We could create a node and add it to the beginning of the linked list, or we can create a node and add it to the end of the linked list. So it's both possible. And it's only that the fact that our linked list is not double the linked list, that basically we don't have the index to the previous one. It may be a little bit different when we're adding element into the beginning or we're adding element into the end as far as the performance. So we implemented the add first, and as you remember, when we added element to the beginning of each node, each list, we just create our node, our new node, and we're going to check if the list is already empty or not. So if the list is completely empty, that means, and we implemented this isEmpty method, that means that nobody is inside, no node is inside this list, and that means the first and last node, they're both null, right? So that's what our isEmpty method is going to check, that if the first one is null, and then we know the first and last also are equal, so they're both null at this point, and that means the list is empty. So if the list is empty, that means this new node that we're trying to add, this is the only node in this list. So that means this is the last and first node. So when we're adding it, we need to make sure that the last reference also referencing to the same node, plus that we know already that first also have to reference to it because we're adding it to the beginning of this list. So that's why we're checking if it's empty. That means that we have to make sure that our last also pointing to it. If it's not empty, then that means there was other nodes in the list, and that means the first was already pointing to that node, and also the last probably pointing to some other nodes already, right? So the only thing we have to do now is that to telling this new node that who is going to be your basically next, right? So we have to maintain that. So this new node, since we're adding it to the beginning of the list, so the next of this node is going to be the very first node that we already had. So basically the place that our first pointing to it or reference, we had the reference of it, or restore the reference into the first. So that's what we're going to do first. We're going to tell the new node that next, that who's your basically next, which is going to be the first. And then when we're done that, then we know that this new node become our first because we're adding element to the beginning of our list. So this was our implementation for the adding element to the beginning of our list. Now we're going to implement another method. Another thing that I'd like to add to this is that sometimes we also like to know the size of our list. So we're going to add another method here. And that's going to be easy, right? So we can add a very simple parameter here, size. And as we adding elements, of course, by default, the value of size is going to be 0. And as we add element to our list, we're going to also increment the value of this parameter. So that way we know that there's another parameter we have to take care of it, and that's going to be the size. So we know how many elements we already have in this list. So that's just another, basically feature to facilitate the users that they're using our linked list. So now next thing we're going to do, we're going to implement a method to now bring elements into the end of the list, right? So basically we're going to call this one add last because we had already add first. So I'm going to call this one add last. Again, we're going to get the element that we're going to store. Right now we decide everything is going to be string, and later we're going to switch to a generic type. So that we already noticed that when we were adding element into the beginning of our list, it was really fast, right? It was just basically the only thing we changed was the reference to the first, right? So we changed the value that or the node that the first is pointing. That was the only main change that we did in order to add an element into this list. So it's really just order of 1, right? So really fast without even realizing we're adding element into this list. So the order of complexity we're adding element to the beginning of this singular linked list is order of 1. Let's see what happens if I want to add element into the end of the list. Right, so again, the first part is going to be the same, right? I need to create a node. And we're going to do the same thing that we did, right? So I'm going to go back to our whiteboard. Hopefully I can manage to do that this time. So if you're looking at our node, so imagine basically, and the first thing is imagine there's nothing in the list, right? So we don't have anything in the list. That means that our first and last pointers, basically, or references, they're both pointing to what? Then there's nothing in the list. They're pointing to both to no. So they're both not. Right? That means that's the starting port, and we don't have anything in the list. So then we started creating our very first node, and we're looking at this node and the fact that the list is already empty. I guess I can also and the fact that the list is empty, right? It was null already. So I know this is going to be the very first one, but I decided that we're going to add this into the end of our linked list. And since there's nothing in the list, right, doesn't matter, right? So basically now the only thing I have to do, like what we did previously, is that making sure the first and last are both pointing to this one because there is no elements in this list, right? So that's become the only element in the list. And since this is the only element in the list, there's nobody after it, right? So automatically the next is also going to be null. And that's because when we're creating our node, the value of next is basically default value. So default value for that next is also going to be null. So nothing is in the list. So that's going to be the first element we add, and first and last are going to be the same. So that's not going to change anything from what we did in the previous code when we adding element to the beginning of the list. Now we're going to add a next node. So we have already this node list, and now we're going to go ahead and add a new node. But I decided that this time when I add a new node, I'm going to add it into the end of this list, right? So this is my new node that I'm trying to add, right? And I want to add it to the end of the list. So the only thing I have to do is that I need to tell the last that, you know, whatever you're used to point to it or reference to it is no longer the last, and this new node is going to be your last. So we have to basically update that link. Also, I have to tell the basically first dot next at this point, or last dot next, because they're both the same in this case, that you have to point to this new node, right? So they're no longer, the next of it is going to be null. Who is next is going to be null, this new node that we just created. That one, the value of it, its next is null. So that's the only difference between the adding element to the beginning or adding element to the end. So we still have to change the address. The only things that we have to change is going to be the value of basically the last, and also the value of the last next. So now let's add another element into the list. So that's now basically this element is no longer my new element, right? So this is no longer new. When we create another one, we're trying to analyze, make sure we're not missing anything, right? So next node we add into the list, the value of our last is going to be changed to this one, like what we did previously. And also the last dot next has to be this new node. And you see, we don't have to play with the first anymore, right? So we always have to maintaining the last dot next and the value of the last itself. So that's only two changes that we have to do. So now that we understand what we need to do as far as the coding, we need to go back to our code. And that's what we're going to do, right? So we're first, so kind of very similar to what we did. If the list is empty, that means that's the only element. So that means first and last, they both have to point to this. So first is going to point to this new node. And also last is going to point to this new node. But if it's not, that means we already have some element in this list. And for that, then I have to tell the last next to point to this new node, right? And I have to tell the last itself that it no longer, the previous node no longer is your last, and this new node now is going to be your last. And of course, in both cases, we need to increment the value of size. So as you see, also we have, after we write our code, we have to do some refactoring. So I have this last in both places, exactly the same. So I'm going to just basically just put it in one place because it's in both of my branches. So I don't need to repeat it twice. We don't like repetition in our code. So that was going to be the easier way to handle that, right? So now we can add element into the end of this list. And that was also order of what? We really didn't traverse, we didn't do anything, right? We just had to change the address. That was also very fast. So that also is going to be order of 1 for us to basically adding a linked list or a new element to our end of our